Okay, so last time we made a Hello World program in which we introduced declaring variables, assigning a value to them, and passing the variable into a function. So before we continue, it's probably a good idea to expand on these concepts a little bit. To do that, let's go ahead and take a look at the program we wrote last time. Okay, so let's go ahead and open this up, open up our Hello World program in Visual Studio. And let's take a look at what we actually did when we wrote this wonderful little gem of a program. So first, Visual Studio created a bunch of stuff for us. It created a class called program. We don't know what that means yet, but that's okay. With a single static function called main. It's good for it and good for us because we didn't have to do that. But what we did was actually add a variable called message. Okay, now adding a variable is called declaring it. Don't ask, just what they call it. So we declared our variable message. We told the compiler basically we need a place to store something. We're going to have some data, we need a place to put it. We called that something message, and we told the compiler that it's going to store a string value. So that's what declaring means. It's basically we told it we're going to have some data and we need to put it somewhere. We're going to call that somewhere message, and the kind of data we're going to put there is going to be a string. Now C# is what they call a strongly typed language. That means that when we declare a variable, we have to give it a type. There is a var keyword. Don't use it. We need to learn to walk before we can run. So if we wanted to create an integer value, it's actually pretty easy to do. So we're going to tell the compiler that we're going to make an integer. Right? We do that by typing int. Okay, then we're going to give it a name. We're going to call it myInt. And that's all we're going to do for now. You notice that the compiler is going to come up and complain that it's declared but never used. It's okay, we can ignore that. So if we assign it a value, we'll do 42, answer to life, the universe, and everything. Compiler's still going to change its message actually. Now it's going to say it's assigned but its value is never used. Again, we don't have to worry about that. Everything is cool. So as an example of what strongly typed means, if we try to assign a floating point value or a double or a float to myInt, the compiler is going to tell us that we cannot implicitly convert type double to int. An explicit conversion exists. I'm not going to worry about converting for now, but I just wanted to show you that that's what strongly typed means. We also can't set it to a string. It's going to complain and give us the same message. Okay, so let's get rid of this and let's move on to functions. We know how to declare variables now. I haven't gone over all the types, but you can get those online. MSDN's a great resource. So we're actually just going to get rid of all of this, and we're going to start declaring some functions. And I just realized that I actually didn't go over some of the structures of the C# language, specifically code blocks. Now, there's keywords. You can tell keywords in Visual Studio because they're highlighted in blue. Classes are actually highlighted in this sort of off blue. And code blocks start and end with the little squiggly brackets. So with code blocks come the idea of context. Now, if you're inside the squiggly brackets inside of a class, you can notice that I can actually declare a variable here, and I'm going to call it memberInt, and that's declaring that this class has a variable called memberInt. We can also do some properties which involve a get set methodology, but we'll go over that a little bit more when we get into object-oriented concepts and things like that. The reason that this is important is that depending on context, that sort of says what you can do. When you're in the context of a function, you can declare a variable. Now this variable is actually only going to be available while this function is running. So if we tried to use message outside this function, it wouldn't work. So context is important, especially when you declare a function. Now, the difference between a function and a variable isn't really a whole lot, actually. A function has a type as well. You can notice that the main function here has a type of void, which is a special type, meaning it doesn't return anything. And for now, we're just going to ignore this static keyword here. We'll get into that kind of stuff later. So declaring a function is done at the class level. So we have to be within the context of the class, but we can't be within a function, right? So let's go ahead and declare a function here. Our function we're going to call Fibonacci, and that's going to return a string, and that string is going to contain a list of the numbers in the Fibonacci sequence closest to the number that we pass in as one of the arguments. So we're going to declare our function here. We're going to say that it's going to return a string. We're going to call it Fibonacci, if I can spell that right. And we're going to say that it takes an integer. We're going to call that start as its one and only parameter. When you declare a function, you have to declare the code block that goes with it. So I went ahead and stuck in the curly brackets. And you can see that the compiler here has complained. It says that not all code paths return a value. That's because we told the compiler that we're going to return a string, but we haven't actually done anything yet. We'll fix the compiler in a minute. Right now it can just chill. Because what we're going to do is go ahead and write the function. Now, one thing that you will learn over time is to comment your code. Always comment, because when you come back to it at a later date, if you just look at the code, it's going to take you sometimes days, sometimes never, to figure out exactly what the hell you thought you were doing. Our comment is just going to be for reference. We are going to go ahead and add the C# indicator for a comment, which is 2 forward slashes. There's another type of comment block that you can do, which is a forward slash plus the star. Now that one you'll need to end with a star and then a forward slash. You see the compiler does this annoying thing of putting in an extra star every time you hit enter. That's to remind you that you're in a comment block, but whatever. So the Fibonacci sequence is, if we have f, it equals f at n minus 1 plus f at n minus 2. Doesn't express very well in the text, but that's basically what it is. A Fibonacci sequence is one number is, the next number is the sum of the number before that plus the number before that. I'm going to pretend for a minute that I didn't actually start with a capital F. Fix that. Now we're going to start with the body of our function. Now a function normally does something. In this case it's something pretty trivial, but that's the idea behind a function, is that you have a sequence of code, or what's called an algorithm. And all an algorithm is just a formula or a series of statements that accomplishes a specific thing. So a function is just an expression of an algorithm, right? You need to do something and you know you're going to need to do it over and over again, so you make a function to do it. Since our function is computing the next number in the Fibonacci sequence, given any number that we pass in, our first algorithm, our first set of functions, is going to need to figure out where we are, what the closest number in the Fibonacci sequence is to the number that we passed in. And that means that we're going to need to write a code block to compute the Fibonacci sequence. So we're going to need some things to do that. And the first thing that we're going to need is a variable to store our current number, and then we're going to need some variables to store the number before that and the number before that. The trick with the Fibonacci sequence is that the first two numbers are always 0 and 1. We'll get to how we're going to do that. So we're going to declare some variables. We are going to declare an int, because we're working with integers here, and we're going to call it current value. Always name your variables descriptively. That means always make sure that the name of the variable indicates what it does, because if I were to go int I, you don't really know what I does if the function is so long that it's scrolled off the page. Then you're going to scroll back up, figure out what it does. It's a pain. So make sure your variables are named descriptively. And in thinking about it, this might not be easy to descriptively name this. We're going to call the next one previous value, and then we're going to need the previous value. So I'm going to call that previous value minus 1. Now you note there's no limit on how long a variable name can be, so take advantage of that. And we've declared all the variables here on a separate line, but we can actually declare them all on the same line if they're the same type, and we can do that just by separating them by a comma. So this is essentially the same thing as we had before. It's just saying that we have 3 integer variables and it's listing their names. We can also actually set the values here. I'm going to set current value equal to 0. I'm going to set previous value equal to 1 and previous value minus 1 equal to 0. Now we're going to introduce a concept called conditional logic. Now, conditional logic basically is just branching the code if a certain condition is met. So this includes if statements, while statements, for statements, things along those lines. So what we're going to use here is we are actually going to use a while statement. And in order to control our while statement, I'm going to declare another variable of type Boolean, which abbreviates to bool. And I'm going to call this done, and I'm going to set it equal to false. Boolean can only be true or false. It's only basically a 1 or a 0. So let's do the actual while statement. So we're going to say while not. Now in C#, the exclamation point is a logical operator, and what it does is it actually takes the inverse of whatever the value is. So we're going to say while not done, and we're going to define our little code block here. What this does basically is it tells the compiler to check this value. Okay, and the not in front of this makes sure that this value is going to be false. So as long as this value is false, the compiler is going to then execute the code that's in this code block. Once it's done with it, it's going to loop back up here to the top and check this again. It's important to always keep your condition in mind, because if we never set the variable done to true, then this statement will never evaluate to true, and we'll get stuck in what's called infinite recursion. The program will just keep going through this loop forever and never stop. Okay, so now on to the function. It's not a function, it's our little code block. What we need to do is we need to, first of all, introduce another piece of conditional logic. And the kind of conditional logic we're going to introduce here is the if statement. Because we've passed in a variable and we want to find the next number in the Fibonacci sequence closest to that number, we need to start our while loop here by checking its value. So we're going to put in an if statement here. We're going to say if. Now, an if statement actually just evaluates the statement that's in between the parentheses, and if it equates to true, then it will execute the code block beneath it. So we're going to say if start, now it's the variable that we passed in, is less than or equal to current value. And we need to open our code block here. So if the start value is less than or equal to the current value, then basically that means that current value is the right number in the Fibonacci sequence. So we are done at this point. So we're going to set done equal to true. The second part of the if statement is the else block. So what this does is it says if this statement evaluates to false, then execute this code. So in this code, we are going to actually put the algorithm for computing the Fibonacci sequence. And how are we going to do that? Well, Fibonacci sequence is pretty easy. We are going to actually set current value equal to previous value plus previous, and I'm going to use a shortcut here because IntelliSense kicks butt, and I can save some typing there. So we've set current value equal to previous value plus previous value minus 1, and that works. But in order for the code to work, we're going to need to set previous value minus 1 and previous value in order to keep those in line with the way the algorithm works. So we're going to set previous value minus 1 equal to previous value, right? And then we're going to set previous value equal to current value. Okay, that means next time we come back through the loop, these values will be set properly. So basically what we've done here is we've made this nice little conditional logic, a while loop, and what it's going to do is it's going to see if our variable that we've passed in is less than or equal to the current value, and if it is, then it's done, right? If it's less than or equal to, the current value is the next number in the Fibonacci sequence. And if it's not equal, then it's going to go ahead and compute the next value in the Fibonacci sequence. So, by the time we're done with our while loop, we will know what the next value in the Fibonacci sequence is based on the number that we passed in. Now what we need to do is return a string that contains that number. We're going to use a little trick here. We're going to use the fact that in C# everything is an object, and the base object that all these inherit from, don't worry about that for now, we'll get into that when we get into object-oriented, but the base class defines a method called toString, which converts that type to a string. So we're going to declare another value here. We're going to call it answer, and we're going to set it equal to the next number in the Fibonacci. Whoops. Jeez. You'd think for somebody who types for a living I'd be able to type better. And Fibonacci sequence is, and we're going to take advantage of the fact that the plus operator is declared and overridden for the string class, and then we're going to take our current value and call the toString method on it. So what this does is it's going to set this answer equal to the next number in the Fibonacci sequence is, and then whatever that current value is. Now we have to return the value. So we have our variable that we've set to the answer. We're going to use the return keyword. This keyword is only valid in functions, and it tells the compiler this is the value that we're returning. So we're going to set that equal to answer, and you'll notice that all of our errors down here go away because we're now actually returning a string. Now that we have our function, we're going to go back up and actually add that to our program. I'm going to add one more thing. I didn't really cover this, and I will at a later date, but this function actually needs to be static, otherwise it won't work. Don't ask why, long explanation. Okay, so through the magic of the internet, and to spare you having to sit through me actually writing this code, I've gone ahead and changed the main function, and what I've done is I've set it up so that it will write out a message asking you to enter a number. This console.read line will actually read user input. I've put in a quit functionality, and down here is the actual functionality that will pass in the number to the function we wrote and return the value. A couple of caveats before we run this. I didn't comment this code as I normally would because I was actually writing it as I was explaining it, so I guess if I ever needed to I could go back to the video. It's not that complicated, it's not that complex. The user code that I just put in, the code to read from the console and write things, go ahead and dissect it if you want, but we'll cover some more of that stuff in greater detail at a later date. Okay, so by holding Control and hitting F5, we run the program. If you don't hold Control, it actually starts debug mode. We don't care about debugging right now. And here's our program that we just wrote. Now, I did notice a couple of things. First of all, we could actually do a better algorithm to figure out the next Fibonacci number. For instance, if I hit 5, which is in the Fibonacci sequence, it will tell me 5. So that's your homework. Although since it's writing code, it's not really work, it's more fun. So that's your home fun, is to figure out a way to have it do the next number even if that number that was entered is in the Fibonacci sequence. I'm a little shocked this works. I actually did this all stream of thought as I was talking about it, so yay, it works. There you go. Have fun.